Hey guys, welcome to another con support video. This one is on comparing constants of proportionality. So let's get into this and see if I can help you understand the concepts here. So let's go. So it says, which relationships have the same constants of proportionality between y and x as the following table? Okay, so basically this is kind of like when we're doing multiple representations. So you can take a constant of proportionality, you can set up a ratio, you can set up a table, you can set up a graph, you can set up an equation. So let's go over that and see if I can help you out. The basics that you want to make sure you understand is that in any proportional relationship, the equation for it is always going to be in the form y equals kx, where x is your input and y is your output. That means that the ratio that has to stay the same throughout the entire relationship is always going to be k, or the constant of proportionality, which is also known as the ratio of y over x, or output to input. And you can see that if you solve for k, that's what you get, right? If you wanted to get the k by itself, you would divide both sides by x. Hence, you'd get k is equal to y over x, just like you see here. All right? So basically, you're looking at any situation that has an equation y equals kx, where the k is the ratio of y over x simplified. That's basically what you're talking about, right? It doesn't have to be simple. It can be any form of 1, as long as it's the same ratio of y over x. But basically, the ratio of y over x is your multiplier. You take that multiplier, you multiply by the input, and you always get the output. When you graph any proportional relationship, the graph is always going to be a straight line that goes through the origin, always. So when you're looking for the graph, is it a straight line? And does it go through 0, 0? Does it go through or include the point 0, 0? If it does, then it's proportional. So this is kind of the things you're looking for when we talk about proportional relationship. It has a constant rate. That rate is the multiplier. It's the ratio of y over x. And yeah, of course, when you graph it, it will be a straight line that goes through the origin because it increases at a constant rate. And it only has multiplication between x and y. So that's why it goes through the origin, because anything times 0 is 0. Okay, let's see, now that we understand the basics of it, if we can apply that pretty quickly. So it says, which relationship have the same constant proportional between y and x in the following table? So the first thing I would do is just look at the table and get a y over x. So the corresponding ordered pair there is 4, 32. So the ordered pair is 4, 32, 4 for x and 32 for y, which means that your ratio of y over x is going to be 32 over 4, which is 8. So that means your multiplier is 8, so you're looking at y equals 8x. Okay, that's kind of the gist of it. That's what you got. So is 3y equals 24x the same as y equals 8x? Well, as you guys know, you can multiply any equation, both sides, by whatever you want. As long as you do it to both sides, you're going to get an equivalent equation. So if you distribute that 3 through both sides of your equation, all terms, 3 times y is 3y, and 3 times 8x is what? 24x. So hence, we can see that these two equations are in fact the same, right? Y equals 8x is the same as 3y equals 24x. So that is good. That's correct. Then you're looking at this one here. And so we see a dot right there. Now, what dot is that located at? So when we're investigating this, right, we see that dot. And where is that dot located? That dot is located at, looks like 5 for x and 3 for y. Okay, so they're basically saying, is the ordered pair 5, 3 the same ratio as 8 over 1 or 32 over 4? And I think it's pretty obvious the answer is no, right? But just to prove it to you, this is your x and this is your y. Is 3/5 the same as 8? I think we can all say safely, no, they're not the same. Okay, so when we're talking about y equals 8x, or a ratio of 32 over 4, or 8 as your unit rate, 8 over 1, then that means that every time the x increases by 1, the y should increase by 8. So it would be a much, much steeper line than this. So this is wrong. Okay, so now we can erase that. We don't need to worry about that anymore. We know that's wrong. Okay, let's look at the next one. Let me just kind of go over to this and write this out again. Sorry. Y equals 8x is what we're looking for. So looking at the next one, every time x increases by 1, does y increase by 8? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So this is when y is 8, x is 1. This dot makes sense. This is an appropriate line. It goes to the origin. It's a straight line. And that order pair 8, 1 exists. 8 over 1 is the same as 8. So that's good. For this one, what's 16 divided by 2? Well, 8 over 1, right? 8. What's 24 divided by 3? 8. What's 48 divided by 6? 8. So in all these situations here, if you take the input times it by 8, you get the output, which means that the ratio is staying the same throughout, and that ratio matches the 8x equation we already came up with, y equals 8x, right? Input times 8 equals y, output, input times 8 equals output, and so on and so forth. So that's a good one. And then this one, 30 divided by 5 is 6. So that's not going to work because it's not a multiplier of 8, right? 5 times 8 would be bigger than 30. 5 times 6 is 30. So this isn't the same equation, right? So that's not going to work. So it looks like you have 3 answers, this equation, this graph, and this table. And we're done. So that's the idea of it. Let's go to the next one. Let me see if I can erase this now. And kind of we'll go from there. So I'm going to leave the ratio of y over x there. I think that's pretty straightforward. I'll leave that up there just so we can keep reminding us of that, okay? So it says Evelyn, Neil, and Leilani swim laps at constant rates. Select the swimmer who swims the fastest. Remember, the fastest swimmer swims laps in the shortest amount of time, okay? So what they're basically trying to figure out is the fastest swimmer swims laps in the shortest amount of time. So you could do it the way they're describing it as the time in, I guess, seconds, and then per lap. So they're saying that in a seconds per lap ratio, you want the seconds to be as small as possible per lap, so that you're basically swinging faster and faster and faster. The other way you could look at it is laps per second, and then if it's laps per second, you want as most laps as possible, the largest laps as possible per every 1 second. It really doesn't matter which way you're looking at it, as long as you understand what you're looking for. So if it's seconds over laps, you're looking for the smallest number to be the fastest. If it's laps over seconds, you want the largest number to be the fastest. But the way they describe it, they're going to do seconds over laps, right? So you do seconds divided by laps and compare the values. So it says here, choose one as the answer. What's the fastest one? So the first one you're going to get here, I think this is just one we just do it in the calculator and make it easy, right? So you got 216 seconds in 4 laps for 4 laps. That's an average rate of 54 seconds per lap. Okay, so for choice A, the rate that you're looking at there is 54 seconds per lap. Okay, I'll do a little L for lap. Okay, and then for choice B, what's the speed at which they're doing there? So choice B says Neil calculates the number L of laps he swims in S seconds using the equation 126L equals 3S. Okay, I'm not really sure why he uses that equation, but he uses that equation. So what you're looking for here is you want the seconds per lap, okay? So if you want seconds per lap, what he's saying is that 126 times the number of laps equals 3 times the number of seconds. So if you think about it, that 126 is related to your laps, and 3 is related to your seconds. Sorry, let me write that out. Okay, so he's got laps. I guess let's put laps on bottom, seconds on top. So he's got his seconds on top, his laps on bottom. And he's saying that basically in his relationship, right? Let's see if this works. He's saying 3 seconds is 126 laps, basically. Let's see if that actually works with this relationship. If you were to look at this ratio and you were to set the cross product for it, wouldn't it be, it'd be 3L equals 5 S times 126. So that's not going to work. That's not the right way to set it up. Let's see if we set up a better way. We want to set it up so that seconds over laps, so that we have the 126 times the L and the 3 times the S. Okay, so now you've got a better situation here. So basically I deconstructed this 126 L equals 3S, and I asked, okay, what proportional relationship would generate this after the cross product? And so as you know, the cross product is going to be bottom times the opposite top equals top times the opposite bottom. So if this is the equation he's working with, it could have come from this relationship, that the seconds is 126 and the laps is going to be 3, right? So 126 seconds for 3 laps. Because when you do the cross product, you get what? 126L is equal to 3S. So I kind of worked backwards from the equation generated by the cross product to find the ratio that we originally started with. And so then once I have this understanding that it's 126 seconds for every 3 laps, right? Then we can, of course, do 126 divided by 3 to get his unit rate. So the unit rate for the second person is going to be 126 divided by 3. Basically laps per second, laps divided by seconds. And we can see that that's going to be 42. So his would be 42 seconds per lap. Okay? And check it to see if it works, right? So if it's 42 seconds per lap, that means when the seconds is 42, the laps equal to 1. So 3 times 42 should be equal 126 times 1, and it does. All right, so now we've got that done. Now we can look at the last one to analyze it. It says here that on her, she's got literally a stopwatch, and lap 1 took 32 seconds. So she obviously is going very fast. So her situation was 32 seconds per lap. She already has this lap 1, and she completed it in 32 seconds. So that's it. So when we're comparing these, the one that had the fastest lap per second time, or the fastest second per lap time, is going to be C because it had the shortest amount of seconds for every single lap. So that would be the answer, C. And now I can go to the next one. All right, so this next one here says, which relationship have the same constant proportionality between y and x as the following table? So if you look at that table, the ratio of y over x is going to be 7 over 2, which is the same as 3 1/2 to 1. Okay? Just divide top and bottom by 2, and you can see that unit rate. Okay, so the unit rate is going to be 3 1/2 for every 1. The equation is going to be y equals 3 1/2 times x, and this is the relationship we're looking for. So it says, which are the same constant proportionality. So when we're looking at this one here, you can think about 1y divided by 4, right? So if you were to divide both of these by 4, you would get 1y equals 14/4 x, okay? Now, is 14/4 the same as 3 1/2? 14 over 4. 4 goes into 14 3 times with 12 with 2 left over. So yes, that's the same. So if you divide both left and right side here by 4, you would get y equals 3 1/2x. So that is correct. And it says when I choose 3 answers. Now 3 1/2 y equals x, that's not correct because it's not 3 1/2 times the output equals the input. It's 3 1/2 times the input equals the output, right? So you got to multiply the x by 3 1/2, okay, and to get the y. So this is not correct. What we're looking for in the graph is a straight line that goes to the origin, which this is. But we want, every time the x is increased by 1, the y is increased by 3 1/2. And it has to include the unit rate as an ordered pair, which is that when x is 1, y is 3 1/2. So when x is 1, is y 3 1/2. It looks like this one is when x is 1, y is 4. So that's not going to match up with what we have. So that's no. This one is when x is 2, y is 7. Now, when x is 2, y is 7 does work because if you plug the 2 into this equation, 2 times 3 1/2 is in fact 7. And we also saw that the original ratio was 7 over 2, right, which is the ordered pair 2, 7, right, when x is 2, y is 7. So this one's good. This one here is when x is 4, y is 14. When x is 4, y is 14 because this is counting by 2, so that's 14. And that already works because we saw over here 4y equals 14. We divided both sides by 4, we got 3 1/2. So that looks like it's going to be pretty good because 2 times 3 1/2 is in fact 14. 2 times 3 is, actually, is it? No, wait, not 2 times. 4 times 3 1/2 is in fact 14. So 4 times 3 is 12 plus half of 4, which is 2 more. So 12 plus 2 is 14. So that does work. So if you were to use this equation, y equals 3 1/2x, you would see that this in fact does work. When you plug in a 4, you get a 14 out. So this is correct. And then you're done. And then the last one is this one here. It says, select the store with the least expensive ice cream per scoop. The least expensive ice cream per scoop. All right, so if we're talking about the least expensive ice cream per scoop, we probably want the cost in dollars, right, in cents, per scoop, right? So we want the cost per scoop. So this one says, store A calculates the total price D in dollars of ice cream with S scoops. Okay, so the way they did it is D for dollars and S for scoops. So they're talking about the ratio of D over S, okay, dollars per scoop. And it says that the ratio is going to be the equation D equals 0.75S. Now, if D equals 0.75S, what does that mean? It means that the ratio of dollars to scoops is going to be 3/4. So that means that basically your multiplier, your cost of proportionality, is 75 cents. So you're paying 75 cents per scoop, right? So that's what this one is. So this first rate, A, is going to be 75 cents per scoop. So you're looking at 75 cents per scoop. Okay? And then B is what? So B here says that dollars is 3, scoops is 3. Well, what's 3 divided by 3? 3 divided by 3 is 1. So basically you're paying $1 for every scoop. Okay? So B is saying that you're paying $1 for every scoop. So that's $1 per scoop. So obviously that's more expensive. Okay? And then the last one, C. C over here says that we've got, okay, where is a clear point that we can look at? So you just follow the line, find one that's perfectly on the grid. Looks like that's pretty good right there. So 2 scoops cost $3. 2 scoops cost $3. So if 2 scoops cost $3, so as an example for this one, 2 scoops cost $3, and you divide top and bottom by 2 to get your unit price, you're going to get 3 halves or $1.50 for every scoop, right? So that's going to be $1.50 per scoop, okay, if you were to think about the price involved for C. So this is as x is 1, y is 1.5, as x is 2, y is 3, as x is 4, what would 4 times 1.5 be? That would be 6, and so you can see that that works out perfectly. There's your 4 and 6 ratio. So that's going to work out. So which one is the cheapest one, right? Which is the one that is the least expensive? So it's A. A is by far the least expensive. So you would push A. You're done. And that's how you do it. Hopefully that helps. And we'll stop.